Hello and welcome to another unusual GCSE question video. This one is a really weird one. It's to do with semicircles stuck around the outside of a right angle triangle. And where's this from?
So this is Edexcel Higher again, and it's June 2022, paper 1, and it's question 13.
And we're going to put that question on the screen there so you can have a look at it before having a look at the solution. Here it is.
Alright, so we're back.
Okay. So this is a proof question, but it's not the kind of algebraic proof we're used to seeing. It's kind of like a geometric proof, and we've got to prove that the area of one semicircle is equal to the sum of the other two. When you do a proof, one thing to remember is don't start with the thing you're trying to prove. You've got to end with the thing that you're trying to prove. You need to start with something that you know is true from that diagram and something you can state confidently about that. So,
because it's a right angle triangle, we know Pythagoras' theorem. So what we can do is we can label these sides here. So C being A. Irritatingly, normally we just label the hypotenuse as C, but because this area is C, I've labelled it like that.
yeah.
So I'm going to adjust Pythagoras' theorem a little bit to C squared plus B squared equals A squared.
Yeah, so we recommend staying with the labels that are on the diagram
Just
rather than,
confusing.
yeah, don't make it more confusing. If you're going to write that though, they don't know where that came from when they're marking it. They don't know what you were thinking, so it's a good idea to write from Pythagoras' theorem.
You're far less lazy than me. I'd write Pythag THM. This is the way to do it.
Yeah, don't do it.
Yeah.
Right. Right, so that's kind of one fact, and then we'll kind of park that fact there, and quite possibly there might be a mark for that. Now, how are we going to proceed? So, it's to do with the areas of these semicircles. So why don't we write down what the areas of those semicircles are? So let's go A. Now it's half a circle. Circle is pi r squared. So it's going to be a half of pi, but r, the radius, if the diameter is A, the radius is going to be half of A. So I'll call that A over 2. And that's squared. And then we're going to square the whole of this fraction. That's going to be a half of pi. Now if you're squaring a fraction, it's important you square the top and the bottom. So that's going to be A squared over 4. And we can simplify that because 2 times 4 is 8. So it's 1/8 pi A squared.
Just to, because that makes me a bit ill, can we just put pi A squared over 8, just so you know? No? It's preference. Okay.
Now, the thing is, because they're working out, this is what I think, because they're working out for B and C is going to be exactly the same working out, you don't have to do that 3 times. You can just say, similarly, B is going to be, what are we doing?
Whatever you
1/8 pi
It's your working out.
B squared, and C is 1/8 pi C squared. You don't have to write all this because they can see it's the same argument.
Do you want me to go from here? Or go on?
Yeah, let's see how Grace would do
Yeah,
this from
okay.
here.
So here you're trying to prove that the area of A equals the area of B plus C. And now we've got all of those 3 bits of information. So I'd start with the right hand side. So I'd do the area of B plus the area of C. Okay, so B plus C, I'll write it how Matt writes it, is 1/8 pi B squared plus 1/8 pi C squared. And then what you can do is you can see that they both have a common factor of 1/8 and pi. So you can take those out, and then that's B squared plus C squared on the inside. And then you just go right back to the start. So go right back to Pythagoras. B squared plus C squared equals A squared. And you can see that is the same as that equals A. And you're done.
Okay. Now I would set that out slightly differently. Obviously, there's nothing wrong with that. That's great. But here's an alternative way of writing it down, and we'll see if Grace hates this. Right. So I would say if c squared plus b squared equals a squared, if I times this equation through by 1/8 pi,
okay, yeah.
it's just an alternative, isn't it?
I like it.
1/8 pi c squared plus 1/8 pi b squared equals 1/8 pi a squared, and we know that they are a, b, and c. So our next line we could just substitute and say c squared.
Oh,
Oh,
no.
What?
Yes.
Yeah, the problem with C's, isn't it, is that the big ones and the little ones are basically the same, aren't they? Is that bigger? That's bigger.
That's better.
Right. So that's c squared, b squared. I wonder why the people who made the alphabet decided that some letters. Oh yeah,
That's what it means.
It's not even right, is it?
That's what it means, because
Right.
that's why I was rubbing it out in the first place.
I was thinking it's because my C wasn't big enough.
No, it wasn't. Because
So many ways this could go wrong.
Yeah. I
Right.
feel like it was better.
Right, C plus B. Anyway, there you go.
Yeah.
That's a slightly different way of laying out the argument. Either way is fine. You've just got to show that you know what you're doing, and that the basic idea is that number one, make it look like you know what you're doing. Second one, don't start with what you're trying to prove. What you're trying to prove needs to be
The last line of the
the
working
last line of the working out. Look for things that you recognise in the question. Write them down. Don't think I've got to here. The next thing I do has got to follow on straight on from here. You can say, well, I'm not quite sure what to do with that. So what else can I do from the diagram? And so right now I'll start dealing with the semicircles. And then it kind of
All comes together.
yeah, you're going to look at that hopefully, and you're going to see, oh look, that's an 8a squared, an 8 pi a squared, and you can see how it matches with this, and then you can pull that argument in and bring it all together like that. That's
Sometimes it's not about getting all of the marks in the question either. You can just look at it and think, right angle triangle, Pythagoras' theorem, you can write that down. You've got areas of circles, you can write down the areas of circles, and if it doesn't all come together at the end necessarily, it is what it
there'll
is.
be a mark for this, there'll be
Yeah.
marks for this. If you get the last bit wrong, you don't need to get 100% to get a grade 9.
Yeah.
So, but anyway,
Yeah, okay.
there you go.
Yeah.
If you've got any other questions you want us to talk about, let us know in the comments, and we'll see you in the next video.